Hi friends, very good afternoon to one and all. This is our topic automatic irrigation system. These are my friends Santosh and Sirisha and myself Niharika. Now we are going to present our presentation. These are the contents which we have, which we will be telling now, introduction and all. Just have a glance of it. Nowadays sensor networks are being used in many areas and in research fields and all, in different fields like medicine, technology, science and all. Now we are implementing science sensor networks in automatic irrigation system. Here we use sensor networks for gardening fields, or for planting, watering plants. Here the sensor networks are currently an active research area, mainly due to its application potential. This project mainly focuses on wireless sensor networks for gardening system. This project is designed to upgrade current irrigation system for garden, which is from manual to timer irrigation system, to an automatic irrigation system by controllable temperature, soil moisture, because they are the main factors to be controlled in precision agriculture. Till now we have the irrigation systems which are manual. Here the person will be controlling how much water should be planted, poured, or and all. Now we are gonna take a new technology, that is we will set the timer, and the timer will be automatically switched off or on when it is when it is done, when the soil moisture is done. Here the first one is the existing technology, where the person goes and waters his garden, water the plants. The next one is the sprinklers. It is a advancement of the first one. There the timer is not set up. Coming to the third one, it is a timer setup. There will set the timer, and it will get off as when the soil moisture is done, according to the timer. The present proposed system is, that is a diagram where these all are the sensors. Then this is the main motor. Here the sensors will send the soil moisture information to the machine. The machine will receive it, and it will process it, and when it senses that the soil moisture is good, then it would stop the flow of water. Thus here the no manual man is required for operating all this. It is done automatically. This is the block diagram of transmitter. This transmitter is present in the sensors. From here the soil moisture is sensed and sent to the microcontroller. The microcontroller sends the soil moisture information to the receiver using antenna. Here we use Zigbee Tarang F4. Yeah, this is a receiver block diagram. Here also we have a antenna. The antenna of the receiver receives the information, and it sends to the microcontroller. The microcontroller processes it, and then it decides whether to switch off or switch on. These are the solenoid valves. These acts as the gates which will open and close. If the soil moisture is sufficient enough, then it will be closing, else it would continue. It would be stayed open. This is the Zigbee antenna. This is a type of antenna. We have different types of antennas. Here we use the Zigbee Tarang 4. And this is the design which we implemented. These are the transmitters. We can implement any number of transmitters as we require, as we need. That is the main master receiver. Those are wide. In that way the antenna transmits the information to the master receiver. Now my friend Santosh will be continuing.
This is a soil moisture sensor we are using in this automatic irrigation system. Here this soil moisture sensor senses the dielectric permittivity, means the it senses the moisture conductivity and converts it into the voltage. and according to that voltage it switches on off the motor. We will set a certain limit of voltage in the microcontroller. According to that voltage the motor will be on and off. Now this is the solenoid valve. Actually we know in everywhere in the field the soil will be wet. The soil condition won't be equally. Somewhere the field will be wet and somewhere the field will be dry. This valve takes the information from according to the moisture in the soil, and it opens the water flow and off. This is the software we use to uh, set up the programming part in the microcontrollers. And this is the algorithm how actually the technology works. Here first the soil moisture sensor senses the moisture content of the soil, and then it sends to the microcontroller which it converts into the voltage, and according to that voltage here we will set the voltage like this. If it is less than 100 means the field is dry. Like this we will set some values in that, and according to that values the motor will be on and off. This is the algorithm where at the receiver, see here only the receiver transmitter 1 and transmitter 2. We can implement many transmitters in the field because the field is very large. We are saying a small model of it. We can implement many transmitters, and all the information from the transmitters is received to the receiver, and according to that we will set some values. Here we use only 2 transmitters. There are 4 conditions for the 2 transmitters, and these 4 conditions are like this. Now these are the results. How actually the it measures the soil content and shows it. Like this, the LCD displays will be there, and it displays the moisture content of the soil and the temperature of the soil. If it is 0, in the before slide I have shown about the S. I have set a value of 100 and 100 to 255. Like that, we will set a value. If it is 0 here, both the transmitters are 0, so it is less than 100. So both the valves are on and the motor will be on. Like this, there are 4 conditions. Here, see, they are 255. It is greater than 100. So one valve will be off, and there the water will not flow. This is another condition. This is one more condition where here 255s means 2 are enough. The soil moisture is enough.
Coming up with advantages, complete elimination of manpower. There is no need of physical work to be done. Work according to the soil condition. Up to date, the record is noted down about the soil fertility. Less cost. It takes less cost. Power consumption is less. Reliable circuit. Maintenance will be good in terms of soil water level by monitoring it constantly. Overflow and wastage of water is reduced. Application, it is used in irrigation field, especially in paddy fields, and in planting, gardening in parks and all, particularly used in fish farming. Future scopes in terms of energy consumption, should plan for the solar panels with the rechargeable batteries to make it self-sustainable. Should establish mesh of networks using high range of Ziga base device to cover entire area. Thank you.
Thank you.
Any questions? Green questions. I have a question regarding water conservation. Do you think this system would save more water, or?
Yeah, this system will save more water because it controls according to the soil moisture, and it switches off and on the motor automatically. So at the end, obviously, it saves the water.
So there is no need of wasting water. It is timing.
There is no need.
Yeah, because it is recorded with time. So according to that, the oil fertility is recorded.
This we can also reduce the human effort and number of people involved in the activity can also be reduced. There is no chance of getting problems and all. Yeah.
Okay. Thank you very much. Question. Here is a question.
They said that they are using a Zigbee technology for that, for using that particular kind of thing. Well, Zigbee in auto transmission, everything we use a Zigbee technology. Do you people use radio frequency even for that? RF signals.
And here is the answer.
Yeah, here we use Zigbee, and here we use Zigbee. We have given the specifications for this Zigbee also. The radio frequency of this Zigbee is 250 kbps. Actually, this is one type of Zigbee which covers a small area of 1 kilometer. There are different types of Zigbees and different types of antennas which can cover even hundreds of kilometers. As the fields are covers more area, that's why which can cover hundreds of kilometers too.
How about the price of the equipment and the software? Is it too much or what?
No, it's a very less cost, because the microcontrollers are very less cost. You know. Yeah.
Very good.
No.
Here we can save the power also in the future. Now it is running on the battery, but in the future we can use the renewable source solar energy, which can save the power too.
Very good.
Thank you.
Thank you very much.